Sometimes, late at night, when the world feels quiet and thin, I like to imagine that the air around me is not really still at all, that it's being brushed by something ancient and invisible, something that has been flowing from the sun since before any of us were born. I close my eyes, and for a moment, I pretend I can feel it on my skin, like a faint, weightless breeze that never stops. A breeze that reaches past Earth, past the outer planets, far into the dark. We have a name for that invisible breeze. We call it the solar wind. It sounds poetic, but it's also real. It's not air. It's not like the wind that moves the trees or ripples across a field. It's more like a constant stream of tiny, charged pieces of the sun itself, flying out in all directions day and night, every second. If you could stand in the open space between planets without dying, you wouldn't feel it on your cheek the way you feel a breeze on Earth. Space is too empty, but it would be there, passing through you, around you, shaping things without any sound. When I was a kid, I used to lie on the ground at night and stare at the sky until my neck hurt. The stars looked so clean and sharp, like they were drawn with a knife on black glass. Back then, I thought space was silent and still, like a photograph. I imagined planets just hanging there, frozen, like decorations. Nobody told me that everything was flowing and colliding and stripping and burning all the time. Nobody told me that the sun was shedding a ghostly river that could peel away the air of a world, or protect it, or reveal its secrets from light years away. Now, when I look up, I see something different. I imagine the sun breathing out this endless mist of particles pouring through the solar system. I imagine it washing over our planet, over Mars, over the icy moons, even over the darkness beyond Pluto. And then I imagine other stars doing the same. Stars so far away that they're just pinpoints to our eyes, but each with its own invisible wind, its own breath, its own way of touching the planets that circle it. And sometimes I wonder, could those winds be the key to finding alien worlds? And maybe one day, alien lives. The solar wind starts in a place we can't visit, deep in the sun's hot surface, where the gas is so hot it's more like a glowing soup of electricity than anything else. In that soup, things are too wild to stay still. Some of it breaks free and rushes outwards. It doesn't stop at the edge of the light we see. It keeps going and going until it fills a huge bubble around our star. We live inside that bubble, like fish in a clear ocean, never really feeling the water until something stirs it. Even here on Earth, we've seen what this wind can do. When it crashes into our planet's invisible shield, it can trigger soft curtains of light in the sky. We call them auroras. I remember the first time I saw one. It wasn't one of those bright, dramatic storms that fill the whole sky. It was quiet, like a faint green smoke moving slowly above a dark field. It felt unreal. The air smelled cold and sharp, like metal and pine. My breath came out in little clouds, and overhead, the sky was alive. That was the moment I realized that space isn't somewhere else. It's here, touching us. Those lights are just the sun's wind, colliding with the thin gases high above us, making them glow. If you listen carefully in a place like that, you can hear the tiny sounds of our own world carrying on beneath it. A dog barking far away, the crunch of snow under your boots, the soft hiss of your own breath in your scarf. Above you, the universe is doing something huge and silent. And below you, your body is just being warm and small. That contrast does something to you. It makes you feel fragile and lucky at the same time. Now, here's where it gets interesting. Our sun isn't special in having a wind. Many stars have them. Some blow gently, some blow like storms. And that wind can reach out and touch their planets. It can strip away air. It can shape magnetic shields. It can carve invisible bubbles in the thin gas between stars. If we're careful enough, if we listen in the right ways, those winds might tell us that there are planets out there long before we ever see them directly. Imagine you're floating far from Earth, out beyond the reach of our own solar wind bubble. There, the sun's breath is weaker, mixing with the thin gas between stars. Somewhere out there, another bubble is pushing back, made by the wind of a different star. Two invisible seas pressing against each other. At that border, things get strange. Particles slow, twist, heat up in ways we can measure. If you could smell anything in space, maybe it would be like the sharp, electric taste of air just before a storm. That metallic tang on your tongue that tells you lightning is close. We've actually sent probes out toward that edge. Tiny machines, humming softly, carrying a piece of our curiosity into the dark. They have no eyes, no ears the way we do, but they can feel the pressure of those particles, count them, taste their energy in a way. From that, we learn how strong our sun's wind is, how far it reaches. And we can compare that to other stars, even stars we can't visit, just by the light they send us. Light, in the end, is our main sense. When we look at a star, we don't just see a point of brightness. We can spread its light out into a rainbow and look at the tiny lines and patterns hidden inside. Those patterns tell us about the star's surface, its temperature, its age, its mood. But they can also whisper clues about its wind. Certain kinds of light are absorbed or shifted by the particles moving away from the star. It's like listening to someone's breath and telling if they're calm or out of breath just from the sound. If a star's wind is strong, it can strip gases from any nearby planet. If a planet is small and close, its air can slowly leak away into space, like steam drifting off hot tea in a cold room. I always think of that when I make a cup of tea at night and watch the tiny white clouds rise and vanish. The smell of it fills the room, warm and earthy, but the steam itself is gone in seconds. A planet can vanish too, just on a much slower, quieter scale. We've seen this happening with some distant worlds. There are planets so close to their stars that they're being boiled and peeled, their gases stretched into long tails like comets. We see those tails when the planets pass in front of their stars, because some of the star's light gets blocked or absorbed by all that escaping material. From here, it looks like the star is wearing a thin, ghostly veil for a moment. From the shape of that veil, from the way the light changes, we learn that there is a planet there, and that the star's wind is strong enough to tear at it. That's one way solar winds give us clues. They expose planets by interacting with them, by making them bleed a little bit of themselves into space where we can catch it. Another way is even more subtle. Planets and their stars have a kind of invisible conversation. The planet's magnetic field, if it has one, pushes back against the wind. You get something like a standing wave, an invisible bow wave, like the curve of water at the front of a boat. In our own solar system, Jupiter does this beautifully. It has a strong magnetic field, and when the solar wind hits it, strange radio waves are born. If you could turn them into sound, you could hear. It might be like soft whistles, shrieks, and crackles, a kind of eerie space music. We've heard similar radio whispers from other stars. Some of them might be from planets with strong magnetic fields, pushing against the stellar wind. We're still learning how to separate those signals from all the noise, from the crackle of the galaxy itself. But the idea is simple and beautiful. By listening to the way the wind changes its song, we might be able to tell that there's a world there, hidden in the dark. I like thinking about it this way. Imagine walking through a forest at night, with your eyes closed. You can't see the trees, but you can feel the wind change as it passes around their trunks. There's a certain hush on one side, a certain rush on the other. The sound of leaves shifts. The air smells different in the shadow of a tree, damp, earthy, a little cooler. From that alone, with enough patience, you could map out where the trees are, how big they might be, how close together they stand. We are trying to do something like that with stars and planets, but instead of air, it's stellar wind, and instead of ears, we use telescopes and antennas. So why does this matter for alien life? Because the same wind that helps us find planets can also decide whether those planets are kind to life or cruel to it. Our sun's wind could have been our enemy. It could have ripped off our air, boiled away our oceans, left us as a cold, naked rock. But we got lucky. Earth has a magnetic field, a kind of invisible shield made by the molten metal moving deep inside our planet. That shield bends the solar wind around us, like a river flowing around a stone. Some of it gets through at the poles, painting the sky with light, but most of it is turned aside. Our air can breathe. Our oceans can stay. Mars, on the other hand, wasn't so lucky. It once had water on its surface, rivers and lakes, maybe even shallow seas. We see the dried up channels and valleys today, like old scars. But Mars is smaller. Its insides cooled down faster. Its magnetic shield faded. When that happened, the solar wind had a chance to bite deeper. Over millions of years, it stripped away much of Mars's air, molecule by molecule, like sand being carried away from a beach by a constant tide. Now, the Martian air is thin and cold. Whatever gentle smells there might have been, wet dust, salty lakes, maybe even the faint breath of something living, are gone. We know this not just from pictures, but from instruments that measured the particles escaping. We watched them streaming away, guided by the sun's wind. From that, we learned that solar winds can shape the fate of a world. They can decide if a planet is a warm cradle or a frozen tomb. So when we look at other stars and try to guess which of their planets might be habitable, we don't just ask, is it the right distance for liquid water? We also ask, how strong is the star's wind? Does the planet have enough gravity to hold on to its air? Could it have a magnetic shield like ours? Or is it standing naked in a storm? Some stars, especially when they're young, are furious. They spin fast, flare often, and blow winds much stronger than ours. If you were standing on a planet close to a young, active star like that, the sky might be full of radiation storms. Maybe the air would glow faintly at night, not from city lights, but from constant energy pouring in. The ground might crackle with static. Rocks might hold trapped particles, like old memories of each blast. Life, if it tried to arise there, would be under constant attack. And yet, I can't help wondering if somewhere out there, life has learned to love that kind of world. Maybe there are creatures that feed on that energy, that curl happily under the constant touch of their star's wind, the way we curl under sunlight. What would their stories be? What would their nights feel like? We don't know. But we do know that if we can measure how strong those winds are, and how they change over time, we can narrow down the places where life like ours might have a chance. We have clever ways of doing this. Sometimes we watch how a star's light changes as its wind interacts with the thin gas floating between stars. There's a special kind of light given off by hydrogen, the simplest element, the same stuff that fills most of the universe. When a star's wind pushes against that hydrogen, it can create a sort of glow, a thin envelope around the star. We can detect that glow as a slight dip or shape in the star's spectrum, its rainbow fingerprint. From that, we can estimate how strong the wind is. It's almost like looking at someone's breath on a cold day. You don't see the air leaving their lungs directly, but you see the little cloud it makes in front of their face. From how big and how thick that cloud is, you can guess how hard they're breathing, how warm they are, maybe even how tired. We're doing that with stars, watching their breath to understand their nature, and by extension, the worlds that might be circling them. Sometimes when I'm alone in a room with the window slightly open, I can feel a draft on my hand. It's barely there, just a hint of cooler air sliding along my skin. If I focus on it, I can tell when a car passes outside by the tiny change in air pressure. I can tell if the night is getting colder. It's like the room is whispering about the world beyond the glass. Stellar winds are like that whisper, but on a cosmic scale. They tell us about the shape of the unseen. There's another layer to all this, one that feels more human to me. When we talk about solar winds and alien worlds, it can sound distant, like a science fiction painting. But the truth is, these winds have touched every part of our own story, too. They shaped our planet's past. They might shape our future. Our technology, our satellites, our power lines, they all live under this constant flow from the sun. When the solar wind grows stronger, when the sun sends out a burst, we feel it. We see it as brighter auroras, yes, but also as disruptions, as signals lost, as systems glitching. It's a reminder that we are still small, still living under a star's moods. And if we ever leave Earth in a serious way, if we build long-term habitats in space or on other planets, we will have to learn to live with these winds more intimately. We'll have to shield our fragile bodies and machines from them. We'll have to design our own artificial magnetic fields, our own invisible umbrellas. In doing that, we'll be practicing for life under other suns, where the winds might be stronger, stranger, or quieter than anything we've known. I like to think of some future traveler, centuries from now, standing in a transparent dome on a planet under a red dwarf star. Outside, the sky is dim and heavy, the light more like late evening than noon, with a faint reddish hue that makes the rocks look like rust and blood. The air inside the dome smells recycled, a mix of metal, plastic, and the faint green of plants. And above, their instruments whisper about the stellar wind outside, about the invisible river of particles sliding past their small world. They know, because of us, how to measure it, how to protect themselves from it, how to read it for signs of other planets in that system. Maybe, as they sip some bitter drink grown from alien soil, they will look up at their strange sky and remember that all of this started with us learning to listen to our own sun's breath. For now, though, we're still here on this blue world, trying to piece together the puzzle. We've detected thousands of exoplanets, planets around other stars, by watching slight dips in starlight, by measuring tiny wobbles in a star's motion. But there are so many more we haven't seen yet, hidden in the glare, masked by distance. Solar and stellar winds give us extra clues, extra ways to guess where those worlds might be, what they might be like, and whether they might be friendly to life. Some of the most exciting work right now is about trying to detect the magnetic fields of exoplanets. If a planet has a magnetic field, it might mean it has a hot, moving interior, like Earth. It might mean it can shield its surface from its star's wind. That doesn't guarantee life, but it's a promising sign. To find those fields, we listen for the subtle radio signals born where the stellar wind hits the planet's magnetic bubble. It's like hearing the faint hum of a distant engine on a quiet night and knowing there's a car out there, even if you can't see its headlights. When I imagine those alien worlds, I try not to make them too familiar. It's easy to picture another Earth with blue oceans and green forests and white clouds, and maybe there are such places. I hope there are. But there might also be worlds with skies the color of copper, with clouds that smell faintly of sulfur and metal, with seas of methane that lap quietly against black, glassy shores. There might be worlds where the wind is so thick with particles from the star that the air itself glows faintly all the time, a constant twilight. On some of those worlds, the stellar wind might strip away the lighter gases and leave behind heavier ones, building a strange, dense atmosphere. On others, it might slowly erode things until only a thin veil of gas remains. Over billions of years, the balance between a star's wind and a planet's gravity and magnetism will write a story in air and rock and ice. And we, light years away, are trying to read that story from the tiny signals that reach us. The beauty of it is that even though we are so far away, the physics is the same kind of particles, the same forces, the same dance between star and planet. When you breathe in now, feel the air fill your lungs, feel the slight coolness on the way in and the warmth on the way out. That air, those molecules, have been shaped by the sun's wind, by Earth's shield, by the long history of our planet keeping its atmosphere. We are literally made of a place that survived its star's breath. Sometimes I think about how fragile that is. If our planet had been a little smaller, if our core had cooled a little faster, if our magnetic field had faded earlier, maybe our story would have ended before it even began. The oceans could have boiled away under a harsher, younger sun. There would be no one here to wonder about solar winds or alien worlds. No one to feel the soft friction of air against their skin on a windy day, or to smell rain coming, or to sit up late and listen to the low hum of a refrigerator and the distant traffic and think about stars. It makes me feel oddly grateful to Earth's molten heart, to the invisible currents of liquid metal deep below my feet. Grateful to the balance that held, by chance or by some deeper rule we don't yet understand. And it makes me wonder how many other worlds out there are getting that balance right now, in this same moment, as we sit here in the dark. Are there other beings somewhere who live under a sky painted by their star's wind, who know in their own way that their air is a gift held in place against a constant stream of energy? Do they have stories about their sun raging and calming, about strange lights in their sky, about storms from above? Do they have words for something like solar wind? Or is it just the way the world is, the background unnoticed, like we once thought of space as still and empty? We're trying to prepare ourselves for that possibility, for the day when we might see a real, detailed picture of an alien world, and not just a faint dot of light or a slight dip in a graph. When that happens, knowing how that world's star breathes will help us understand what we're looking at. Is that planet's sky thick or thin? Does it have clouds? Could liquid water exist on its surface? Could life, any life, have a chance to arise and endure there? And even before we get those pictures, solar and stellar winds are helping us narrow down the search, like adjusting the focus on a camera in the dark. We look for stars whose winds are not too wild, not too weak. We look for planets at just the right distance, with just the right size. We look for signs of magnetic fields, of atmospheres holding on in spite of the constant push from their suns. The universe is big, and we are small, and our tools are still clumsy. But little by little, we're learning to read the breath of stars. Sometimes, late at night, I like to open a window just a crack and let the outside air drift in while I sit in the dim glow of a screen. I imagine that somewhere far away a star is blowing a wind across its own system, touching its planets, some barren, some maybe not. I imagine that on one of those worlds, someone or something is also sitting in a room or a cave or under a tree, feeling a breeze and wondering what lies beyond their sky. They don't know we exist. We barely know they might exist, but we are both, in our own ways, living under winds from our suns. There is a quiet comfort in that thought. A feeling that, even across impossible distances, there is a shared pattern, a shared physics, a shared vulnerability. We are all, in some sense, leaves in a cosmic wind. In the end, solar winds are not just a scientific curiosity. They are part of the story of how stars touch their worlds, how energy flows, how atmospheres grow and fade, how life might rise or fail. By learning to listen to those visible streams, we're not only finding alien worlds, we're learning what it means to be a world at all. Next time you step outside and feel a real wind on your face, take a moment. Notice the way it moves around your body, the way it tugs at your clothes, the way it carries smells. Wet pavement, cut grass, exhaust, leaves, the faint salt from a distant sea. Remember that above you, beyond the blue, there is another wind, one you cannot feel directly, but that has been shaping your planet for billions of years. Remember that every star you see in the night sky may be doing the same thing to its own hidden planets. Somewhere in those unseen currents there are clues about rocks and oceans, about air and clouds, about chances for life. We are just starting to learn how to read them. We are like children cupping our ears to a seashell, hearing the faint roar and realizing it's not the ocean inside, but a hint of the world outside. We listen, we measure, we imagine. We send out little machines to taste the edges of our sun's breath. We build bigger telescopes to catch the faintest changes in starlight. We try to make sense of it all with equations and models and late-night arguments over coffee that's gone cold. And beneath all that, there is this simple human feeling, a desire not to be alone. Solar winds won't answer that desire by themselves. They won't suddenly show us cities on distant planets or voices in the static. But they help us find the places where just maybe something could be looking back. And that to me is enough to sit with for a while. To imagine a universe where every star is not just a light in the dark, but a breathing thing, sending out a silent, steady exhale into the void. Where every planet is a small experiment in balance, in resistance, in survival under that breath. We are one of those experiments. Our atmosphere, our oceans, our bodies, our thoughts in the middle of the night, they are all part of this delicate dance between a star and a world. When we study solar winds, we're not just learning about alien systems. We're learning about the invisible threads that tie us to our own sun and to everything else. Somewhere, far beyond the reach of our own solar wind, in the truly deep dark, the particles from our sun finally lose their strength and mix with the rest of the galaxy. They carry with them a tiny trace of where they came from, a faint memory of our star. Maybe one day particles from other stars will drift here, and we will catch them and read their stories. Until then, we listen to the winds from afar. We watch for the way they sculpt light and gas. We search for the worlds they reveal and the lives they might allow. And as we do, we're slowly answering an old, quiet question. What does it mean for a planet to exist in the breath of a star? In the stillness of a room at night, with only the soft hum of electricity and the distant murmur of a sleeping world, that question feels strangely close. It sits beside you like a friend, not asking to be solved, just to be held for a moment. We are here, in the wind of our sun, aware of it, thinking about it, using it as a key to worlds we cannot yet touch. That awareness alone is a kind of miracle. In all this vastness, in all this motion, a small patch of matter has become able to wonder about the invisible breeze that has always been there. And as long as we keep wondering, as long as we keep listening to these faint, cosmic whispers, we remain connected to our own star, to distant stars, to possible strangers under other skies, and to the deep, quiet mystery of being anything at all, in a universe that never stops breathing.